I will be talking about Apostel, and the Apostel project has already ended 4 years ago, and we are still working on this without getting any money. So this is really real research spirit, I would say. So here are my colleagues from Graz, and I'm Tobias, and I also used to work in Graz, and now I'm in Tallinn, at Tallinn University, where we're continuing also some of this stuff. So Apostel is a adaptive system that is used at the workplace, and we're following their adaptive learning systems paradigm. So it means the learning system tracks what people are doing with it and makes some inferences about some of the characteristics of the user, and then gives some recommendations what they should be doing next. And one of the problems with adaptive systems is that, at least in traditional systems, this user modeling, how it was called, was very often secretive. So the system made some inferences, but the user wasn't really aware of that. And this is the problem that we are tackling with this system that we are presenting today. So opening up the user model and visualizing the system to the user to, of course, also make it possible for the user to reflect about what the system knows about him. So I'm going to be very quick today. Just 3 things I want to talk about. 3 of the main issues that we had with this system. So we are talking here about an open-ended learning environment that is used in the workplace. So people should be using this as part of their normal work. We are talking about fairly large and complex learning domains. So they're not so easily modeled as maybe some subjects in the educational field. And we wanted to present results of implicit diagnosis. So not present people any tests or so they have to fill out, which we found not really to be appropriate in a workplace setting. So and therefore my experience was created, and it is non-invasive, and it should reflect what people are naturally doing at their workplace with Apostel. Because it's a large and complex learning domain, of course it has to reduce complexity, has to fit a lot on the screen. We saw some nice visualizations today, which also went into the same direction. And because it's all implicit, it has to be somehow intuitive, because people are not actually noticing what's happening there, and it also has to be correctable. So we wanted people also to be able to correct what the system knows about them. So there has been some work in non-invasive knowledge assessment, and it has been used in educational systems, and I've listed some of them here in adaptive systems. But in workplace systems, we found this has not been the case to the same extent. So most of the work has been performed in the educational domain. And of course, open learner models have been around for now quite some years, and they have been found to enhance reflection about the learning process, but also these results mainly pertain to educational settings. And here are some of the assumptions that we had. These were also empirically found within the project. So at the workplace, we assume that learning is mainly self-directed, and it's driven from the tasks that people are working with. That learning makes use of existing resources. And these resources are organizational resources, so they are not necessarily designed for learning purposes. We assume that learning at the workplace is a social process in which people also switch roles all the time. So at one point they might be learners, at some point they might be working in a domain, at some point they might be supporting others. So frequent changes. And we also assume that there's a lot of research showing this, that experts actually act differently than novices. So it's not just a matter of doing the same thing better or more of the same, but they are just acting differently, and therefore we thought more appropriate model here would be to look qualitatively also at what people are doing. So not only have a score from 1 to 10 to measure their expertise, basically. And here's how Apostle looked like. So was a result of a 4-year research project, and we have people working at the workplace. So a system is designed for knowledge-intensive work, like engineering, consulting type of work, and you see that it is just running along the normal work tasks that people are doing, and it recommends, for example, some resources, some people, some experts that might be helpful for the task that a person is doing currently. There are some communication mechanisms, so you can contact these persons, ask questions, get help, and you can also design kind of your learning goals in a certain domain, and then get reminded of new materials that are made available. So that's just to give you the context of where we're doing this. The Apostle user model is an overlay of the domain model, as is also very often the case in adaptive learning systems. So Apostle is a generic application, and it gets basically instantiated by domain models. So here you see 4 workplace domain models that we have modeled and that we have used Apostle with. So innovation management, regulations on chemicals, simulation in electromagnetism, and here are some of the partners that we work with. And here is what EADS is doing. Yeah, so they are dealing with the situation that what happens when your plane gets hit by lightning. Does it still fly, or does it drop to the earth? So it seems to be quite a important thing to worry about. Yeah, so that was the. So they're writing basically simulations on electromagnetism. So what happens in these events to the airplane? And here you see, the kind of entities that we modeled. It's not the whole domain model, but that's what is important for this talk today. So we have modeled some tasks in these domain. We have modeled some topics, and a very simplified view on part of this domain model is that a certain task requires learning of certain topics. So that is the basic structure. So that also allows us to infer, for example, that when people are frequently working on a certain task, that they might have knowledge about certain topics. I said we wanted to make this assessment implicit, so we are just basically observing what we call knowledge indicating events. So all the events that happen in Apostle that we think have give us some indication on the kind of knowledge that somebody has about a certain topic. And we have separated this assessment into, let's say, 3 levels. So we want to find out whether somebody is rather a learner, rather looking for information on a certain topic, whether he's or she is a worker. So that would be someone doing tasks but not asking other people very frequently, or whether one person is a supporter, so supporting others in their learning. And here we have some of the knowledge, some of the events that we are tracking, and where we classified basically this event. And then the algorithm is very simple at the moment. It just is kind of a majority voting. So for one topic, if people do a lot of learner events and only very few worker and supporter events, then we assume they are learners, and the other way around. And then you have some neutral events that we haven't really classified here. So, and here it's how the user model looks like. So this has been the result of basically 2 strands of research. So one is the whole development of this application was heavily user-driven. So users were involved. So this is through several iterations. So this is not only some idea we had and then implemented it, but it actually went through many iterations, the whole system, but also this user model part. And the second one, we employed some principles from information visualization, which I'm going to show later on. But let me just give you an overview here, what you see. So you have these three areas or knowledge levels that we assumed. So whether you're a learner, whether you're a worker, or whether you're a supporter in different topics. And the topics that you see here are then the topics from the domain ontology. And as I said before, depending on what you are doing with the system, so whether you're looking for information or creating some learning paths, that will decide in which part of the learner model this topic will be put. The colors show, the intensity of the colors shows how frequent these interactions have been. So some principles from information visualization. So it's very well known that people are quickest to find certain things in these tree views. So therefore we have also provided this tree view visualization where you can just drill down through the hierarchy of the domain ontology. And coordinated with this, we have a tree map view. It means that's a space-filling visualization. So it means it puts all the information you have on one screen. So it gives a very good overview of what has been your main areas of work, for example, and where have you been doing things. So that's one of the Ben Schneiderman's information visualizations principles. So you should give an overview first. So that's why we decided for this tree map. But then you should also give possibilities for people to drill in. So you can have a filter here. So you start typing just a full text search, and then it filters out the things that you started typing. And you can drill in by clicking. So if you click here, for example, then it zooms to show more details. And the detailed view then looks like this. So you have here the element of creativity techniques. And there you can see what kind of events the system tracked. So, for example, this user selected three times selected learning goals about creativity techniques, performed a topic, so it means selected the topic and looked at the documents, and 12 times performed a task. So, therefore, this user was found to be in the. I think the colors are mixed up here in this, so it should be a learning should be on the learning side. Okay, and then you could also actually go back to the events that you actually performed. So if you, for example, know that you were looking for something on creativity techniques, then you could actually revisit the search that you did maybe a few days ago or a few months ago. So to conclude, the knowledge indicating events, as we have defined them, track the naturally occurring interactions in this learning system. The tree map visualization is intuitive, and it was also accepted by the users. We haven't made usability studies, formal usability studies, but it was more informal evaluation of people actually using this in the workplace. And they found this especially helpful for comprehending the domain model, so what the domain model actually entails, and also to enhance their reflection, so to see what they have been doing over the past few months. And we're currently analyzing more in a data-driven manner actual knowledge indicating events that people have produced at the workplace over a few months periods, but this will then be a paper for the next conference. Okay, and then I can report finally that we got a new project just accepted at the EU. So we are now moving to more traditional industries with this approach. So not to engineers and consultants, but actually to the construction site where people are running around with their mobile phones. And we want to put much more emphasis on learning analytics, social semantic learning analytics, so how these models that in Apostel we had basically fixed now actually emerge in their work. And yeah, it's quite a large project, and it was also very well received. So if you are a student, or if you know a student that would like to be involved in this type of work, I'd be happy to talk to you or in the break. All right. Thank you very much.
Thank you for the presentation. One question I have is regarding that 3 layers you talked about, worker, supporting, and learner. What is the rationale behind defining these layers? Is it based on literature or requirements of the workplace, like the specific domain? And then what is the reason behind the mapping of those knowledge indicative events and each specific layer? I mean, why do you say that editing and annotation is an indicative of a supporter role, but like creating the annotation itself is done by a learner? Thank you.
Yeah. So first question, where do these 3 levels come from? Well, as I said, we assume that experts just do different things than novices. So that should also be reflected in the sense that they're doing different kinds of things with the system. So that was the basic assumption behind it, and there's quite a lot of research showing this. The 3 particular levels came from many different, for example, from research into knowledge work that look at how knowledge workers actually deal with information at the workplace. So there's like conceptualizations there that suggests that you can differentiate it into these 3 basic activities. You could, of course, try to come up with much more fine-grained analyses, but because this was really designed for workplace practice, we needed kind of the metaphors and that are very intuitive, so that people can take one view and basically understand. So that was also one of the reasons that we simplified this approach very much. And then it was very pragmatic approach that we took. You could, of course, employ, and I'm sure many people would be interested to do that, some machine learning or something like that to classify now what other people doing and then classify them into these 3 levels and so on. But yeah, that is future work, and we wanted first to see how far we can get with this very simplistic approach.
Use an exciting microphone. One of the interesting things, I like the solution to the problem with scrutable user models, because they are difficult for people to understand. But it makes it easier to game the system. Did you find examples of people deliberately modifying their user models?
No, because the user model is just for themselves, so nobody else can see it, and there's not really any use in doing that. I forgot to say that you can actually, you don't even have to game, because you can just click on one of those elements here and just change the level. So if you feel that the system has misclassified you and that you are rather a supporter, but you're not, the system hasn't tracked that, you can just change it. And actually the ones that have the star here, that's where people actually did this. And the only effect this has is that you're getting different recommendations, which I haven't talked about now, from the system, and you're getting different behaviors of the system. So there's not really use in gaming.